Today we are going to evaluate this limit, and the limit is limit x approaches infinity of 3 raised to power x plus 4 raised to power x over 5 raised to power x. So we have been given this function, and we have to find out that what value does this function approach when x approaches infinity, or infinity means a very large positive number. So if we put infinity in place of x, infinity is not a defined number, but just for the sake of showing, if we put a very large number in place of x, then these terms 3 raised to power x, they and 4 raised to power x and 5 raised to power x, they all approach very large numbers, meaning they approach infinity. So in the numerator we get two large numbers and their sum, which is another large number, over infinity, a large number. So we get an answer which is not, we can't really tell that what is this value. So this is an indeterminate form, and this is not the value of this limit. So we have to come up with some way to get rid of this. And how can we do that? We can do that by dividing the numerator and denominator by 5 raised to power x. And what advantage do we get by dividing this fraction by 5 raised to power x? In the denominator we can see that we have only one term, which is 5 raised to power x. So if we divide by 5 raised to power x, we get rid of the infinity in the denominator and we get 1 in the denominator. So this is the advantage which we get by dividing by 5 raised to power x in both the numerator and denominator. But if we divide by 3 raised to power x, or let's say 4 raised to power x, that won't make things easier for us, because in the numerator there are two terms, and if you divide by 3 raised to power x, you'll get 1 plus 4 over 3 raised to power x. So 4 over 3 is greater than 1, and a number greater than 1 raised to power infinity is still infinity. So you'll get infinity plus 1, which is infinity. So even by dividing by 3 raised to power x, you didn't get anything other than infinity in the numerator. Similarly, you'll also get infinity in the denominator as well if you divide by 3 raised to power x in the denominator. So, and this also happens when you divide by 4 raised to power x. So the only way which makes this question easier is by dividing both the numerator and denominator by 5 raised to power x, because in that way we get 1 in the denominator. So I did that, and I ended up with 3 raised to power x plus 4 raised to power x over 5 raised to power x divided by 5 raised to power x over 5 raised to power x. In the denominator, both 5 raised to power x cancel out, and we are left with 1 in the denominator. In the numerator, we can separate these two terms with the denominator 5 raised to power x. So this becomes 3 raised to power x over 5 raised to power x plus 4 raised to power x over 5 raised to power x. If you combine these two, you get this numerator. Basically, it's just the reverse of taking the LCM. So what you get is 3 this thing over 1. So when both the numerator and denominator have the same power, you can write that power as a whole. So I can write this as 3 by 5 whole raised to power x, because when this x distributes to both numerator and denominator, we get this thing. And similarly, we get 4 over 5 raised to power x. And if we look closely, 3 over 5 is less than 1 because the numerator is less than the denominator. So we'll get, if this was 5, then this would have been equal to 1. 5 over 5 is 1, but this is not 5, this is less than 5. So this whole fraction will have an answer less than 1. So this is equal to 0.6, and 4 over 5 is also less than 1. This gives us 0.8. So whenever you have numbers which are less than 1 and they are raised to some power, here the power is x and that power is huge, so they follow a pattern. These numbers which are less than 1, when you raise them, when their power gets bigger and bigger, their answer gets smaller and smaller. So if we take 0.2, which is less than 1, and raise it to higher power, I have raised it to 2 here, which is very small, as which is not comparable to infinity, but just for the sake of concept, if you raise it to 2 power, you can write 0.2 as 2 over 10, and if you square it, you get 4 over 100, which is 0.04. You got a number which is smaller than the original number, and if you take its cube, you get an even smaller number. So whenever a number less than 1 is raised to higher powers, its answer gets smaller and smaller and closer to 0. So here we have two numbers, 0.6 and 0.8, and they are raised to power which is very huge. So in the numerator, we'll just apply a property of limits, that the limit of sum of two functions is just the sum of limits of those two functions. So we get this limit and this limit, and obviously when x gets huge, this number gets close to 0. So we can, this limit is equal to 0, and similarly this limit is equal to 0. So 0 plus 0 is just simply 0. So the answer is 0.